Um, come on. Anyway, and obviously carbon dioxide would be one carbon and two oxygens, right? And which of these is ionic, which is covalent? Just to remind ourselves, it's not really what today is about, but
carbon dioxide is covalent.
Good. What's it mean to be covalent?
Everything, let's say in the formula, has to be on the right side past that red staircase.
Yep, that's right. Because why? What are they doing in covalent compounds? They're sharing. And those are the only ones rich enough to share their way to a full shell. Absolutely. Now remember that the periodic table gives us the average mass of every element. I'm going to say every atom. And so we can use this information to find the average mass of any compound. I'm going to give you a minute to write that. Take your time. There's no rush. There's a little rush. Don't take like all day, but there's no meaningful rush. And then we'll look at an example. While you do that, I'm going to sip my coffee.
What kind of coffee?
Tim Hortons dark roast, which normally I drink black, but the problem is if you get it black, it's still hot like an hour later.
You know people who drink a decaf?
I sometimes drink decaf if I want to enjoy a cup of coffee, but like anytime after say 1 p.m., if I have a cup of coffee, I'll be up all night. So if I want to have a coffee in the afternoon, I'll drink decaf. Normally I just don't. Usually after like 9 a.m., I switch to tea.
What kind of tea?
I like all different kinds of tea, but I love an Earl Grey tea. That's kind of my favorite. Like English breakfast. I like just black teas in general, but I like green teas.
I forgot how to make my tea, so.
I used to carpool with a woman, Sahar, and she would every morning make me like this wonderful like Pakistani chai tea, and it was so good. Oh, it was great. She would make me tea every morning, and she said, quote, "Your car is an embarrassing piece of shit, so let's take mine instead." So it was great because not only did she make me tea every morning, but no, it's true. In fact, she would insist that I not park in front of her house. So she would have me park in front of her neighbor's house. But it was great because, and then she would never take gas money from me. So it was great. I actually saved a lot of money by virtue of having a piece of crap car that Sahar didn't want to be seen in. I mean, my car was pretty embarrassing at the time. It was a 1995 Pontiac Grand Am, and it was in rough shape. I bought that car for $350. And it wouldn't die. I had it all the way. It was our second car all the way to when I was working here. And I wanted nothing more than for that car to die. And it just wouldn't. Everything broke on it. The radio didn't work. The windows didn't work. Only one of the doors would open. The heat like had two settings, which was fully hot or not on at all. The air conditioning like had a constant leak. So I was constantly having to pump new refrigerant. Like just everything about this thing sucked. But the engine just would not die. And I always said to Brett, like, when it dies, I'm going to buy, like, a decent car, at least, for the first time. That's when I bought my Volt that I drive. So it was about 7 years ago. That was my first year here. And then finally one day, I got out to the parking lot here. I went to start the Grand Am, and it wouldn't start. I went, oh, finally it died. And so I went down to the shop, and I said, like, hey, I'm going to donate my car to you. I'm going to go buy a new one. And this is back when Uncle Paulie was here, Mr. Fortin, old auto teacher. Like 2 hours later, he came down and he's like, oh, yeah, it was just like the terminals on the battery we rusted. We sanded those down. She fired right up. I was like, no, it's still alive. And I had to drive it for like 6 more months before it died. Yes, windows. That's so weird to me that you guys, like, because when I was a kid, if somebody had power windows, you're like, oh, bougie. Like, it was so fancy. Yeah, like... Yeah, it's cool and it's annoying is what it is. Yeah. Well, Mr. Calford, Mr. Calford the other week said he went through the drive-through window and he pressed the down button on his window and his whole window just went, fell right down into his car. He was like, oh, I don't have a window anymore. You had to go get it fixed. Can you imagine? That's never happened to me. My parents were so broke. I remember they had a car that the only gear that worked was drive. So it could not go backwards. Like it couldn't go in reverse. So they had to very carefully park it so that you could always pull out straight because the reverse gear just didn't work. Yeah.
How did they how?
Right? So they had to park on the street. Well, and like you could also put neutral and roll it. So sometimes you had to be thoughtful and like if somebody had a steep enough driveway, you could just put neutral. But I remember more than once having to like push my parents' car backwards so they could like get it to a place where they'd be able to start it and go forward. Yeah.
Isn't that like illegal?
Yo, very. Yeah. Not safe. Not safe. So you kind of charge those like I'm old, guys. It was like 36 years ago. Not that I remember it, so I guess it wouldn't be 36 years ago. I probably wasn't helping push a car at 4. But anyway, the point being, it was a long time ago. Let's look at an example.
For the car or for...
No, for this.
Okay.
Example 1. What is the mass of an oxygen molecule? And just a reminder that the term molecule means what? Does anyone know? If you see the word molecule, it means it's this kind of compound. A molecule is another word for a covalent compound. So we don't use the word molecule or we shouldn't use the word molecule when we're talking about ionic compounds. We still do sometimes, just for convenience sake. But remind me, oxygen, why is it a molecule? Why isn't it just an atom? Oxygen is one of our diatomic elements, so it's always found in pairs, right? Oxygen is O2. And the reason for that is, of course, oxygen has 1, 2, 3, 4, 5, 6 electrons in its outer shell. A full shell, it would be how many? 8, and so it shares this pair, and it shares that pair. How do we draw that more often? We don't have to worry about this too much, but usually we don't draw all the electrons. For covalent compounds, yeah, for covalent compounds, we draw a line between them. Not for ionic compounds, but for covalent compounds. But just a reminder that oxygen is diatomic. It comes in pairs. Oxygen gas is diatomic. So it's O2, not just O. Okay, well, this one's pretty trivial then. How much does this molecule weigh? Well, how much does an oxygen atom weigh?
16.
Yeah, this says 15.9994. So to one decimal place, it would just be 16.0. Does that make sense? I'm going to use this number, actually, because, well, we'll use 2 decimal places, which would actually be 16.0. So each oxygen atom, I'm going to have to plug in. That's annoying. I forgot to plug my computer in last night. Fine, I'll sit at the desk like a 1960s teacher. All right, each oxygen atom weighs 16 AMU. And I'm going to just remind us where we see that. Usually they would put the number 6 up there, and down here it would say 16.00. That's the weight, right? Good morning. Thank you. So, no need to overthink this. If each oxygen atom weighs 16, how much does an O2 molecule weigh, where you have 2 of them stuck together? Yep. Be bold. Yeah.
32.
Beautiful. Very good. And how'd you do that?
16 times 2.
Beautiful. Exactly right. And so we're going to introduce the symbol we usually use here, which is big M. And we use big M for atomic weight. and then I'm going to use a subscript to say what we're talking about. So we're going to say the atomic weight of oxygen is just 2 times the atomic weight. I shouldn't say atomic weight because that's not, I'm going to say formula weight. That's another term we'll use because we're not just talking about an atom here. And that's going to be 2 times the molecular weight of oxygen, just like Mantha Kamakai said. And so that's going to be 2 times 16.00. And I don't know if I've done this before, but U is the same as writing atomic mass units. It's just a little bit quicker. And so that tends to be what we use. That's actually a Greek letter mu. It might be the Greek letter mu. Don't quote me on that. But it just looks like a U, except it's got a little tail on the front as well.
It looks like cursive.
Yeah, kind of looks like a cursive U. And Mantha Kamakai, remind me, what's 2 times 16? 32. Very good. 32.00 atomic mass units. How's that feel? Not too bad? Straightforward, right? Now, that's obviously a pretty easy formula to work with, but even still, you get the idea, right? Which is that all we have to do is look at the formula, and remember, a formula is just a recipe, really, right? It's just tells you how many things are in it, and we just have to add all the weights together. Can we do a slightly more complicated one?
Wait.
Oh, yeah, sure. Take your time. Sorry. Thank you for slowing me down.
I'm gonna go cry in the bathroom.
If you think it'll help.
Okay.
I know, but what in God's name? What the hell?
What?
Who would do this? And why would they do this? And what, like why I hate people so much? Look at that. What?
How's it even get that bad?
Why is it even open? Like the whole point, I have this whole thing wired and everything was zip tied to the side, so that all you have to do is plug this in. That's all. Oh,
I don't want to blame it.
I mean, I think somebody's trying to be helpful and was like, oh, I should plug it in. Oh, where's the plug? Oh, I know. I'll rip the whole thing apart. But, oh.
Mr. I don't know.
Do I help you with this?
Mr.
No, it's
Trish
okay, yeah.
was ridiculous.
It's okay. I'll deal with it later. Actually, maybe I'll make sense in the basket. That's good.
I was working on the Chromebooks last year.
I know, and you did a really good job. I really appreciated it.
I don't think I finished though. I just stopped getting Chromebooks to work on.
No, but you made a big difference. Actually, it was much better than you had done.
Well, that's nice to hear because nobody ever told me that.
Did they not?
No.
Well, I would have told you.
I went to go take Trish's computers and he was like, "Can you clean them?" And I was like, "Okay." And they were nasty. Some of them could not even be cleaned.
I know. Can I tell you? I clean these ones every week. Every week. And you would think, how dirty can a computer get in a week? Well, let me tell you guys, real friggin' dirty. That's how dirty. Like, oh boy.
I'm allergic to dust.
Ugh.
Open those.
The worst of my life was I was the computer site manager when we sent 212 computers home during COVID, and then when they came back, oh, it was horrifying. It was horrifying. I cleaned them all, and they were just like, oh, I wore a respirator, I wore elbow high gloves. It took me like 4 days to clean those computers, like 4 full, like 8-9 hour days, and they were just, oh, it was revolting. But they were sparkly when I was done. Like some of them I had to like completely disassemble and like run the case through run the plastic parts through the dishwasher because they were just so filthy. Like vacuuming them, compressed air, alcohol. A couple of them I actually, this is completely true, took in the back and lit on fire. That's how frustrated I was by it. Yeah, no, I sprayed some alcohol on it and I just burned it.
Yesterday.
That was can I say, I look back on those COVID days and I'm like, man, I was in a dark place. But I did that on that back, like right in the back there.
Nah.
Or where's the tarmac? Like there, right over there by the auto shop.
Nah.
It was like 8 p.m. and I had like one computer to go, and it just looked like somebody had just, I don't even know. I don't even know. It was crusty. It was crumbly. There was just every type of crumbly bit imaginable on it. I just thought, I'm not doing this. Very like Chromebook that like is missing 3 keys, and like somebody's ripped the webcam off, and so I just took it in the back and I just put some alcohol on it and lit it on fire. Yeah.
TV shows where the hoarders.
Right. Yeah. Yeah.
During the Chromebooks, 2 of them were just like on fire. I didn't let them that way. I was like cleaning them. The webcams were just smoking.
Yeah, that's because people pull them off, and then when the wire is exposed, yeah. Not good. Not our best moment. Okay, let's try another one.
Who does that?
Most of the webcam Chromebooks are
What they
missing.
normally do is they'll like turn it so the camera's facing up, and they'll just rip it off.
Yeah. Love people. Love people. Anyway, what's the formula? Okay. What's the formula weight of, and we're going to go sodium nitrate. Now, of course, before we can figure out the weight, we're going to have to figure out the formula, but that's okay. We can do that. So sodium nitrate, the symbol for sodium is Na. How many electrons does sodium want to lose?
No.
Uno is correct. We look up at the periodic table. We see it only has 1 electron to give away. And then nitrate, the fact that it ends in 8 means we're looking up one of our radicals, right? That's not on the periodic table. Nitrogen's on the periodic table, but if it was sodium and nitrogen, it wouldn't be sodium nitrate. It would be sodium nitride, right? So the fact that it says 8 means we have to look it up. Now, because I do this for a living, I know it. It's NO3. And what's the charge?
1.
Yeah, so it wants to get 1 electron. Well, the nice thing with that is if sodium has 1 electron to give and nitrate has 1 electron it wants to get, what's the formula? NaNO3. Okay. So, really quickly, how many sodiums does this thing have? 1 sodium. How many nitrogens does it have? 1 nitrogen. How many oxygens does it have? 3 oxygens. Good. Oh my. Okay. So when we go to find its formula weight, what symbol do we use for molecular weight / formula weight? We just used it up here. We use an uppercase M. It has to be an uppercase M. You have to be careful because anyone who's taken physics, what do we use lowercase m for in science? Just the mass, but the mass of like a thing. Like, so if we were measuring the mass of like a real physical thing, we'd use lowercase m. But big M stands for like this theoretical mass. You know, how much an atom weighs or how much a molecule weighs. And again, the term we use is either molecular weight or formula weight. In this case, because it's not a molecular compound, we're not going to say molecular weight, we're going to say formula weight. And I want you to get in the habit of always putting subscripts on things. All right, using subscripts will help you keep track of things. All right, in math, they always kind of just do the math and then they throw the unit on at the end, right? That probably rings a bell. Your math teachers just put the numbers up there. That's not how we do things in science. We always write every unit as we go. And we'll talk about why that is, but it really helps you avoid mistakes. Units are your friend. In math, we treat them like an annoyance, and you come to think of them as like the annoying thing that you lose a half mark for because you forgot about them. But in science, especially in chemistry, the units will give you the answer. Because if you know how the units work, it'll tell you what math to do. The units actually tell you what math to do, and we're going to really think that way. All right, so what is this thing made of? Well, it's made of a sodium, so we need to say how much a sodium weighs. And then what else is it made of? It's made of a nitrogen, so we're going to add that to it. And that's made of 3 oxygens. Now listen, don't write this yet. I suppose I could do this, but is there a better way to write that? Could do, but they're not stuck together in that way. Instead, let's just say, and like I won't find O3 on the periodic table. So instead, what I'm going to say is just 3 of those. You can put a multiplication symbol in there if you like. In fact, I'm going to put a multiplication symbol in there rather than being like a math guy and just knowing that if you write 2 things next to each other. So what this is saying is, if you want to find the formula weight of sodium nitrate, all you have to do is look up how much a sodium atom weighs, add it to how much a nitrogen atom weighs, and then you're going to have to look up an oxygen atom, but because we have 3 of them, what are we going to do with that number? Times it by 3. Does that make sense? All right, we're just adding, but in this case, we're multiplying because we've got more than one of them. If you wanted to add it 3 times, you could. It's just clumsier, but that's fine. Like if that makes it clear to you. And so now we just have to look these up. Now you've all got your periodic tables. I've got this one here, which I feel guilty. I gave this to my grade 9s. Somebody emailed me this one. I'm like, oh, it's colorful. Oh, it's nice. And then when I print it, I'm like, oh, the font is like so small that it's like impossible to read, especially if you have old man eyes. But I'm looking up sodium here. And when I look up sodium, I get that it has a mass of 22.99 atomic mass units. Just about 23. Well, we're going to do a whole day on decimal places and rounding. Depends on the question. Depends on how accurate you need to be. No different than I'm framing a building right now. I just finished all the framing. When you frame, you kind of do everything to the nearest 1/8 of an inch. Does that make sense? It's all going to be inside the walls anyway. You might even do it to the nearest 1/4 inch. It just isn't that important. If there's little gaps in your framing, that has nothing to do with, nobody's ever going to see it. It's literally inside the wall. I started drywalling yesterday. Am I going to leave gaps all over the drywall? Yeah, because you tape it and compound it anyway, right? But as soon as I'm done with that, I'm going to do all the trim, which is like the visible stuff that'll be available. Am I going to do that to the nearest 1/4 inch and leave big gaps everywhere? No, because it'd look like crap, right? Does that make sense? So just like in real life, in science, we are as accurate as we need to be. Does that make sense? So for now, until we do our day on decimal places, I'm just going to say, let's live in 2 decimal place land. But then when we do our whole day on decimal places, we'll learn that like how precise you need to be depends on what you're doing. All right? If you're designing, a pacemaker that's going to be put in somebody's heart and have to stay inside them and keep their heart beating for the next 60 years, you're going to build that thing pretty carefully, right?
What about, say, like a nano?
Or even something like, even this, where I needed to make an adapter so that this lens piece could sit inside of this because they don't fit, right? These are mismatched. And so here, I had to use Autodesk Inventor and build a little piece. And it had to be really precise. It had to fit perfectly in here. This has like a circle and a smaller circle in it. And that needed to fit this. And I needed it all to fit snugly so it wouldn't fall out, right? Like, so that I had to engineer to really be a tight fit. And it's funny, I can tell it's cold in here because it's loose. If I warm this up with my hand, it's actually so kind of close to perfect that if I let this get warm, it'll expand just a little bit and it'll be rock solid tight in there. It won't be able to come out.
How does it vibrate?
I know, right? Yeah, metal in particular like really expands as you heat it up. Yeah, so it depends. Nitrogen, if you look up on your periodic table, it should be 14.01, or sometimes it's 14.008, whatever. Do you guys have your periodic table? If you do, get it out because it's helpful. But that's 14.01 atomic mass units. And then we have to do 3 times, and we've already done oxygen. How much does oxygen weigh? Do you remember? 16.00 atomic mass units. By the way, you don't have to memorize any of these, but you will. Those ones that you use all the time that you're going to memorize, not because I say, hey, you have to memorize this, but because it just happens. And then other ones you won't memorize and you'll look up. I teach this for a living, and I could not tell you the formula weight of gold. I don't know. I'd look it up. I think is it over 200? It might be the last one under 200. What's gold? Yeah, gold's last. It's mercury that's 200.
So you don't round everything.
These are rounded. These are rounded, but they're rounded to specific places. In this case, they're rounded to how many decimal places? Listen, you can go look these up online. You can find some periodic tables that have this to 12 decimal places. That's not true. That we're not that precise. But you can find periodic tables that have these to 6 decimal places. So they're all rounded. It's just a question of where they're rounded. Does that make sense? Cool. And I'm going to write... I always think, even though it's kind of annoying, it's good to be really neat and orderly with your math. I always leave a space between lines. See how I space things out? You guys have a real habit. I read your lab notebooks and you're like, everything's like super crunched together and you'll do like 8 questions on one page. And it's like, oh my God, just let your work breathe. Just give it some space. Math likes to breathe too. All right? And see how I always line my equal signs up? That's a nice form. Like it'll help you avoid mistakes. And so then, here's the other thing I want to teach you, which is, I don't know what your other teachers teach you, but they're wrong if they don't say what I say right now. And I don't say that very often. Usually I'm the like, however you do it is great if it works for you. Okay, ready for me to finally be snotty about something? When you use your calculator, do everything in one step. Does that make sense? Which also means you need a decent calculator. If you try to do this crap on your phone, you're going to make mistakes because phone calculators suck. They're just not good. All right? If you do want to use your phone, download Desmos Scientific Calculator. It's a good one. It's a good app. But your default phone calculator app is a piece of trash. Don't use it. It sucks. All right? The Apple one's bad. The Google one is somehow worse. The Samsung one, the less said, the better. But they all suck. They're no good. Yeah.
What makes them bad?
They don't have any kind of tactile response when you hit a button, and it's so easy to hit the wrong button. But then they're just set up like, the problem is they're set up like elementary school calculators, right? So like when you say +3, it just changes to the new answer. Whereas like in modern good calculators, show you your work as you go along, and they don't calculate until you press enter, right? I love Desmos Scientific Calculator. Desmos is actually, I mean, this is life-changing, where if you wanted to, you could actually say a sodium atom weighs, what did we say it weighed? 22.99. And then we could say a nitrogen atom weighs 14.01 or 2. I'm having a moment. 1, yeah. And then an oxygen atom weighs 16.00. And then you could actually say that sodium nitrate just has a mass, is the mass of sodium plus the mass of nitrogen. It doesn't like my second subscript, I don't think. No, doesn't like that subscript. So I'm just going to. And then plus how many oxygens? 3. Now, I'm not suggesting you do that, but see how advanced this is? Like, that's kind of incredible, right? Now, having said that, I don't actually suggest you do all that. That's more work than you need. But here's what a good calculator lets you do. On a good calculator, as you type, it just keeps the information on screen, and you can do it all in one step. So we're just going to say 22.99 plus, what next? 14.01. Whoa. Plus 3 times and 16.00. And altogether that equals 85. Now, the reason it isn't putting decimal places here is because 0.99 and 0.01 actually cancel each other out, right? That ends up. Having said that, how many decimal places are we showing in this? So how do I want to write that? Just to show that I haven't rounded it. Very good. Exactly right. So we're going to write this as 85.00 atomic mass units. And I could write AMU, but more often we just write the U to symbolize that.
Yeah, this one's so clear, guys. Like in that case, if you have caps lock on your phone,
Yeah.
and you need the other button, you have to take it off and flip your phone.
I've always thought what would be a great device, because I love the phone screen and that. I always thought a great thing we would have in schools is there's something that just like snapped onto your phone, and then like you could Bluetooth connect it, and you could have like real calculator buttons, but then have like the work be on your phone, and then also like slide and stuff like that. Because the real problem is the keyboards, right? Like if you try to do advanced stuff on your calculator, you end up, even with Desmos Scientific, which is great, if you have a smaller phone, the buttons are so small. But then if you use the app with the big buttons, things slide all over the place. It's clumsy. So I always thought that would be a great business for schools. Yeah.
Can you show on the screen what the U thing looks like on Google or something? Because I'm kind of writing it and it's looking a lot like an M.
Yeah, let's, there it is.
Okay.
So it's literally a U with a stick. It's a mu. It's the Greek lowercase mu. Greek letter.
Sometimes with like energy drinks, it's like say like you're going down to the very bottom when there's some sort of like vitamins, and then I see that with a G.
Oh, interesting. Oh, that's micrograms.
Oh, micrograms.
Yeah, which is not a lot at all. And you want to know what a great calculator is? OneNote. Like, look how nice this is. I just typed that in there. Watch. Boom. Isn't that great? OneNote really is wonderful. It's, can I just show you, like, just to show you something? Like, you want to see what OneNote can do? And I'm like I need to update my OneNote, but I've been slow to because I'm just worried that I will mess stuff up. But like, if you're in a math class, watch this. Now, let's see if it'll, like, watch what OneNote can do. Oh, it never likes my X's because they look too, like, not like X's. So let's try that again. Okay. Like, watch this. Sorry, one sec. I do want to answer your question. See that? I just wrote it and it knows what I did. And now watch this. I could solve for X. And I could say, well, how'd I do that? I've got to show my work. Oh, there's how you did it. Isn't that incredible? I could be like, oh, graph that for me. There it is. Isn't that amazing? Just from my handwriting. Crazy. We live in crazy times.
Did I use this on an open book test?
Here's the deal. Like, it depends on, so we are taking, like, if I'm teaching you chemistry, can you use that to do your to do the math? Yeah, of course. Because, listen, if anyone in here gets in the habit of using Desmos, or you'll see when we get to dimensional analysis, I built a calculator, Mr. Orlando's dimensional analysis calculator. I'm currently working on version 2.0. But it is the only calculator in the world that I've ever seen. I think I've actually built something that nobody else has that actually does calculations, not just with numbers, but also does the calculations with the units too, which is pretty cool stuff. Yeah, you can use that because this isn't a math class. The important thing here is, can you apply math? Now, if I was teaching you math, would I let you use that? No, because it's not doing you any favors. Because we do ourselves a favor when we get good at, see, like, if I use that as a shortcut now, it's a useful tool for me because I could 100% do it on my own. I've done it a million times, right? So for me, it's just saving time, but I understand what it's doing. Does that make sense? And the danger, and for chemistry, I don't care if you understand what the math is doing. I just understand that you can do it. Does that make sense? This is a practical, skill-based thing. And that has nothing to do with you being college-level students. By the way, that's just as true in the university-level chemistry. I don't need you to be mathematicians. I just need you to get the answers. I don't care what tools you use. But if I'm across the hall teaching you math, well, now I need you to be good at not just getting the answer, but I need you to be good at doing the math because we're going to use that to do more math later on. Does that make sense? Likewise, if I was training you to be a mechanic, I need you to understand how the engine works. If I'm teaching you to drive, I just need you to understand that when you press the start button or turn the key, the engine goes on, and then like the one pedal makes it go faster and the other pedal makes it go slower, and you turn the wheel to turn. You know what I mean? They're different requirements. Chemistry is driving a car. Across the hall, they have to teach you how to build a car. That's why math class is harder. This is also why everyone's always like, I understand math so much better than you teach it. I'm like, no. You're better at math when I do it with you because I'm not making you understand it. I'm just making you do it, and that's okay. That's appropriate. Calford's got the hard job. He has to teach people to understand the math. And they don't let me do that with anyone older than like grade 9 or grade 10. Then they know I'm not smart enough. Oh, Calford's brilliant. Calford is one of the smartest human beings. Like, you guys don't know what you have, and having Mr. Calford, he's like, oh, it's hard. I don't get it. And then when other people teach me, I'm like, no. The reason you understand what Mr. Calford teaches, because Mr. Calford teaches hard math, right? That's fine. Mr. Calford is probably the best math teacher in the DSBN. And he's certainly, like, the stuff he makes, every school in the DSBN uses. Like, any school you go to, anytime I go to any other school, I always pop in the math. Every math room has all kinds of stuff Calford's built. It's a new grade 9 curriculum now, so our old thing, but he built like a culminating activity. Maybe you did the Jeopardy thing, and maybe you're like, oh, that was stupid or annoying or whatever, but I'll tell you, kids, like, the culminating assignments we used to give would be like 12 questions, and kids would do like 8 of them and hand it in. Calford builds this thing, and all of a sudden kids are doing like 200 practice questions and getting great at stuff. Eastdale, scrappy little Eastdale, beats the province every year on grade 9 EQAO. We did last year, we did the year before, we beat the DSBN. We punch right up there with like the richest schools in our board. He's a tremendously impressive math teacher. A few years ago, we sent 2 students to Centennial because we weren't running calculus, Stephen and Alex Zhang. You know who got the 2 highest marks of 3 of like the 130 kids who took calculus at Centennial that year? You know who got the 2 highest marks? Stephen and Alex Zhang. The year before that, we sent Krish Patel to do advanced functions there. And of the like 200 kids who took advanced functions at Stanley, you know who got the highest mark? Krish Patel. Cassie Sparks, you know, we sent to the... Sorry? Yeah, like honestly, Kelford's something special. I'll tell you this, anytime I don't know what I'm doing, you know where I go first? Right across the hall. And Kelford goes, oh yeah. I'm sure I've told you my coding adventures where I'll spend all day on something and then I go over and show Kelford and I'm all proud of it. And he's like, oh yeah, I have an app that does that. And he'll pull up his code. And my code is like 6 pages and his is like 1 paragraph and just like, and I will tell you something else. A few years ago, I started showing him how to do some stuff in Microsoft Excel. And he hadn't really worked with it much before, and I'd used it a lot, like when I was in university, because you use it for everything in science. Probably the most useful skill. We're going to get doing some Excel stuff this unit, because it's the most useful skill I ever learned. I am actually pretty convinced that Mr. Calford is the world's most advanced Microsoft Excel user. He has Excel doing stuff that it has no business doing. It's wild. Absolutely wild. You'll go over there and you'll be like, hey, you know what I just built? I just built something that will randomly generate a Sudoku based on the difficulty level you want and make you a solution page for it. And you're like, oh yeah, I made my coffee too weak this morning and it didn't taste very good. Yeah. Anyway, okay. So now, yeah.
What are Calford's weaknesses? Just asking for a friend.
Well, like most people, he needs oxygen to breathe and a steady supply of water and food and human kindness and love and...
I'll keep that.
Okay, let's try one more. But I want to make a note first. Just a note on the words we use. Note on language.
Are we running that?
Yeah, no, please. Uppercase M means either molecular weight. I'm just going to show you the words you'll see used. Molecular weight, formula weight. You're going to see the term molar mass, molecular mass, formula mass. These all mean the same thing. Specifically, we use formula weight when we're talking about ionic compounds, because ionic compounds are big dumb rocks, right? Remember that? So they can just keep growing and growing and growing. There's no individual molecules in a big dumb rock. So for ionic compounds, we can't say molecular weight because there aren't really molecules. There's no discrete things. Molecular weight we use for covalent. You'll see these other terms. They're all synonymous. And sometimes, very often, you'll just see weight. What's the weight of? And the truth is that's kind of clumsy. We shouldn't say that, but we do. So just be aware that these all mean the same thing. They mean how much does this thing weigh at the atomic level when we weigh out its atoms. Which, by the way, can we actually do that? Are we going to go in the back and get like real fine tweezers and weigh out individual atoms? Yeah, Hannah High is. Hannah High's got very delicate fingers. She can get those atoms one at a time. Me, big fat fingers. Terrible piano player. Victoria. Have we discussed how you have piano player hands before? Is this a thing we've discussed? Hold your hands up right now. Do you play the piano? No. Oh, you've got piano playing hands. Oh, actually, I am so jealous. This whole table right here, hold your fingers up. Yeah, you have like smaller hands, but even still, like you've got, for the size of your hands, you've got like long, slender fingers. See yours. I saw the same thing. You're a bit more like me, but better than me still. I've just got stupid little sausages stuck to my wrists, and I can't, I'm so jealous of, I watch Chuck play guitar, and he's just so smooth, and then me, I've been playing guitar since I was 10, and I still look like a rank amateur, because I've just got these stupid little sausage fingers. Sorry?
Do you want to hear me play guitar?
Yes.
Amazing. I actually kind of do.
I do too. And then piano, I can't reach anything. My daughter is my daughter's half my size, and she can reach farther than I can on the piano. Anyway.
When I was in music class, they wouldn't let me play ukulele or piano because my hands weren't working.
That's all. Yeah, I do not have very coordinated hands. I am not Mr. Fine Motor Skill, I'll tell you that much. If my handwriting didn't give it away to you, I struggle with fine motor skills. Anyway. Okay, let's try one more example. And you're going to see that these are all the same, but you notice how if I give you the name, what's the first thing you have to do, of course? Well, yeah, but you can't do the big M of something until you know its formula, right? So, in this case, we're going to look at what is the molar mass, or the molecular weight? Nope, I want to do, yeah, okay, let's do, what is the molecular weight? So are we talking ionic or covalent compound here if I said molecular weight? Covalent. And we're going to do of glucose. How much does a glucose molecule weigh? Now, does anyone remember the formula for glucose? Grade 9 science or biology if you've taken it. It's a sugar. It's a ring of
There's like
C6,
12, like
H12, O6. Very good. All right. So I want to know how much a glucose molecule weighs, and it has the formula C6H12O6. So let's put that here. All right. And for now, listen, when we actually get going, you will never write this out. Does that make sense? Like once you actually get good at this and used to this, you're never going to waste the time to kind of show this unless it's something big and complicated. If I'm honest, sometimes when I'm dealing with something big, I will still write this out. But for now, you see how we took this first step, and before I jumped into numbers, I wrote what we were talking about? I want you to do that for now, just to help that as a peace of mind. Yeah?
You have to do that math ABCD or whatever.
Yeah, like quadratic equation. Yeah. Yeah. So same thing, I want you to just show me this step for now, because when we did NaNO3, we said, okay, that's a sodium and a nitrogen, but then we have to take the mass of an oxygen. And why did I multiply it by 3 here? Because I had 3 oxygens. So here we have how many carbons? How many hydrogens? How many oxygens? Awesome. See if you can work it out. And 2 decimal places is cool for now. Your periodic tables are to 2 decimal places. If you're looking off the board, you can do it, but it typically has 4 or 5 decimal places. So it's going to make your math a little trickier. But that's okay. I respect tricky math. Oh, ah. What about me? Tatiana and Caitlin.
Wait, does
I
Hofsprinkles
don't
have
have
this?
my thing on.
It doesn't matter here. Hofsprinkles only when things are on their own. So nothing to do with when it's in a compound. Is that what you're asking?
So if you're writing it as like 12H, that's fine.
Yeah, that's, yep. And again, but put it in front, right? Just say say that if that's what you're saying. Cool. I'll be right back. Oh.
Mr. Orlando, you have my lab, right? Like
Yeah,
my lab
yeah, I got it. Oh, my bad. I didn't talk about that.
Okay, so that's my answer. Okay, let's see here. Carbon. Now hydrogen is just 1. So it would just be 12.
There should be a free cart. If there's not, let me know. We can work with that too.
Oh yeah, I can't stop it.
Oh. Oh, I moved
So what we just
32
did here,
sheets of 5/8 drywall from a truck into my
Wait, would it be?
construction project yesterday.
Are you sure you sent it to me?
Wait, yeah, you would.
I thought I just sent it. Let's take a look.
About the
Yeah, I just sent it to you. So try refreshing.
about the you were talking
Two
about
decimal
like
places, so it would be 12.
how you wish you had like
Well,
the calculator or something you could plug in.
Yeah.
And think. It reminds me of like I remember my brother having like an Xbox controller, and then he had this little piece where you plug in the charger, and it's like have like letters in it, and you just text.
My favorite phone I ever owned. I had this Motorola phone. I actually had 2 of them. Like I updated after like 2 years. And Motorola was doing this thing where they called it Moto Mods, where they had all these attachments that just magnetically grabbed onto it. And so like one was like a Polaroid camera, which was like kitschy and stupid, but one was like a 360-degree camera. One was like a video game controller. One was a speaker. One was a projector that would project up on the screen. And they just snapped onto your phone. And I loved it. And I thought, what a great system this is. One was just an extra battery, so it made your phone thicker, but it like tripled your battery life. It was so great. And I loved that phone. And when it broke, I was like heartbroken. I got my stupid new phone, which I've had for like 4 years now, which is a Galaxy, and I hate it. I hate everything about it. But I'm a cheapskate, and I refuse to. Yeah, sure. Yeah, sure. No, please.
So what we did with this,
Mhm.
I'm doing here, right?
Beautiful. Yep.
But I don't put this 6 here because this is here.
That's right. Yeah, that's right.
Well,
And because you won't find C6 on the periodic table. So the whole reason we write this way is we're like, what can I find on the periodic table? There's no C6 there, but there is.
that's
Parts one
Yeah,
how
so we just do
That's
running
Yeah,
anyway,
okay,
so.
thank you.
Oh, sorry. Run into people here. Oh, stiff. Oh, don't get old and out of shape, guys. Stay in shape or just stay young. Whichever one's going to be easier.
Stay young. How do you stay young?
Well, like
Young
me,
and
you,
old.
like me, you keep your finger on the pulse of youth culture. I'm hip, guys.
Oh,
So hip.
well, saying that does not make you hip.
Does Paul McCartney wear a wig?
I doubt it.
He's in his what, like 80s now?
Yeah, can I tell you, I saw, my friend Amy and I went and saw a Paul McCartney concert, geez, I guess about 10 years ago now. And I was like, I've gone to a lot of concerts, a lot. I've probably been to, conservatively, I bet I've been to 500 concerts. I've been to a lot of shows. It's my thing. That's what I spend money on. So I'm fairly hard to impress at this point, just by virtue of having done this a lot. Man, I saw Paul McCartney. Dude was 70-something at the time. Played for like 3 hours, super high energy, voice was amazing. And then you just sit there and go like, this one guy wrote all these songs. It's just insane. Like when a guy can do a 3-hour concert and just every single song is like an iconic song, you're like, all right, this is actually quite impressive. Just the voice. Oh, the voice. And at that age, like he is not a young man at this point, and still, oh God, if I could sing like that. If I could sing like that, I'd never stop. I'd sing every lesson.
Then you'd lose your voice at some point.
He makes like
Well, that's the thing too, is he gives it, right? Like, I'm always amazed by singers who, because even like if I'm doing a 3-hour gig, you can't give it for 3 hours, or I can't, because your voice will just start to go, right? So you got to lay back and, sing a little more softly and pick your moments. And yeah, he just like was up there just like giving her. I don't even understand it. It's very impressive.
okay, 180.18.
Well, let's see. That's what we got, eh? How do I do it? What do I have to do here? Because C is carbon, so I would look that up on the periodic table. But how many of them do I have? Yeah, and so I'm going to kind of do this in parallel lines here. So I would go look at the periodic table, and I'd say, okay, I need 6 at, how much does it weigh?
12.01.
Okay, and then I'm going to show you something that probably you've seen in math, but we have a habit of when we substitute, we put it in brackets. Have you seen that before? That's kind of something we do often in math to show that that's like something we've substituted in. So I'm going to model that for you here. And if something's next to a bracket and it doesn't tell me what to do, what's the default operation in math?
Multiplying.
Yeah, in math, the default operation is always multiplying. So if you write 2 things next to each other, it means multiply them. All right, what do I have next? I have 6 carbons. Keep going. 12 hydrogens, good. And that is going to be, is it 1.01 on your periodic tables?
Yeah.
It'll be 1.0079 if you look it up on that one. I think 794, sometimes they put the 4 on.
Pretty much 12.
Well, pretty much. It'll be 12.12, right? Which isn't the same as 12. And that's what we're going to talk about, is that it depends on how careful you need to be for being kind of just...
We don't need to make like a NASA rocket.
But for now, we're always going to assume I want how many decimal places? 2. Well, again, we're going to do a whole day on decimals. And then how many oxygens do I have? 6. So we're going to do 6 times the molecular weight of oxygen, which is 16.00 atomic mass units. And then we're going to do this calculating. And am I going to do all those multiplications, write down the answers, and then add them together? No. We're going to just do the math. 6 times 12.01 plus, keep going for me.
Plus 1.01 times 12.
Yep, 12 times 1.01.
Plus 16 times 6.
Plus 16 plus, and yeah, and like, don't worry, like how you did it's totally fine. I'm going to show it in the same order I wrote it here, so if people come back and look at this note, the order makes sense, but what you're doing is just as good, makes no difference. And we get 180.18, right? So a glucose molecule weighs 180.18 atomic mass units. Wonderful. We will always have the yellow calculators here, and if you don't have your own scientific calculator, feel free to use them. You never have to ask me, just come get one. Always make sure they go back where you got them. It's good to be consistent with what calculator you use if you're not super math comfortable, so that you get used to like kind of how you do things on your calculator. We're not doing any complicated stuff really on these calculators. A couple times we'll have to use the exponent button. That's about as complicated as it gets. Multiplying and dividing and adding and subtracting is mostly what you do in chemistry because it's all recipes. But just to remind ourselves what this means, a glucose molecule weighs 180.18 atomic mass units. Now, as always, if you want some practice with this, where could you go? Practice app. All right, if you go to the practice app, Teams.
What about, you said you were going to talk about lab stuff.
Yeah, labs. If you haven't handed your lab book in, hand your lab book in. I want by tomorrow. Also, most people actually gave me assignment 2, which is good. But I want that by tomorrow as well. So if you don't have assignment 2 done, get it done. If you need help with it, where could you come? I'll be here after school today. I'm here at lunch today. The other thing is I am looking for volunteers, and I'm going to mention this in all my classes. I want to get a bit of a kind of after-school help going every day where I'm available to help people, which I'm doing now. But I also want to get some volunteers. If you're comfortable helping, say, with grade 9 or grade 10 science or grade 9 or grade 10 math, and you'd be interested in some volunteer hours, and there's maybe 1 day a week or 2 days a week where you'd be willing to stay after school and help out. I know I have a few kids in my grade 10 class who I need to get really working with, and there's enough of them that I'm not going to be able to do it all myself. Does that make sense? Which is not a good thing, but I'm going to be giving the same spiel to people who've already taken this class and trying to find some volunteers for you. If you're behind in any of your classes, I don't care if it's an English class or a French class, and you want a place to get caught up, where there's always a teacher after school between Chuck and I, there's always someone here. But the other thing is come talk to me. We can make a schedule, but I also... in addition to helping you myself, I can find some people who can sit and help you on a more regular basis. So if you're interested in, sit down. I don't do the thing where we stand up and put our coats on and go stand by the door. Sit. I'm not letting you leave if you're not all sitting. Get to your desk, sit down. So if that's something you'd be willing to do, come chat with me. Because yeah, I don't want to do the thing where I wait until midterm and start going like, oh my God, these people are way far behind. I just came out of Unit 1 in my science class. I know they just came out of Unit 1 in the other 9 and 10 science classes. So it's a good time to help get people get caught up. And if you need help getting caught up, come talk to me. Have a wonderful day, guys. All right.
A thermometer and a small blade or knife to crush.
Do you have a binder?
Yeah.
Oh, good.
I just want to make sure that I formatted this all correctly.
Looks beautiful. Yeah, that's perfect.
Okay.
That's
And
perfect.
today, 4:30.
Yep, sounds great. I will be here.